Okay, for our last two presentations this morning, staff members from the local Natural Resources District. First up is Jocelyn Vanderslice. She's a Water Resources Manager with the Upper Elkhorn in O'Neill. She's been with the NRD system for about 2 years as a research technician and Water Resources Manager. Jocelyn works on water quality and quantity projects, has a bachelor's degree with a major in geoscience from Chadron State College. Oh, okay, so Wade's before Jocelyn. I'm going to go ahead and introduce him then. Wade is with the Lower Niobrara Natural Resource Districts. Wade has monitored and managed the district's groundwater programs and analyzed their phase data, presenting results to groups from across the Niobrara Basin. He grew up on the Niobrara River and has a heritage that's been rooted along its banks for more than 100 years. Wade has a bachelor's from University of Nebraska and is currently a participant in Nebraska Water Leaders Academy.
Thank you, Dr. Snow. Everybody here okay? Hopefully it's not too loud. Jocelyn and I were asked to come bring a little background information and a little bit of monitoring data from the Lower Niobrara NRDs and the Upper Elkhorn NRDs. We're going to go through what we've been doing with our phase information that the producers are giving us in our district, and then Jocelyn's going to go through the Brazil Groundwater Management Area survey that we went through this last winter. Bear with me. I'm going to skip a couple of slides here at the beginning just so we don't double up on some stuff and maybe save a little bit of time. Wrong way. There we go. Here we got the Nebraska nitrate map. You can see up here, the Lower Niobrara NRD. Below it is the Upper Elkhorn. And right over here would be the Brazil Groundwater Management Area. And those are the areas that we work in. A lot of times you see these red dots and it says over 20 parts per million. To a lot of people that might be 21. In all actuality, to us, it's quite a bit more than that. Skip ahead. I think Dr. Snow did a very excellent job of explaining the risk in these areas where you have physical soil properties that are large, grained, have a tendency to transfer water very quickly, depth of groundwater that's very shallow, and these intensive cropping and livestock systems just create the perfect storm to affect your groundwater quality. In the Lower Niobrara, you can see when we started monitoring groundwater quality in 1996, we were already significantly above the MCL. We're up here in the 15 parts per million range. This constitutes about not quite 500 irrigation wells that we test semi-annually, and you have a large range of 1.1 up to last year we set a record and had a helper well that was 78.3 parts per million. In the Upper Elkhorn, you see the same thing. Back in 1997, they were also above the MCL for nitrate contamination in groundwater. And again, this steadily increasing trend line. And this pool of data represents about over 500 wells, irrigation wells that they check on an annual basis. When you break it down into a township map, it's not very pretty. In the Lower Niobrara, we've got a lot of townships, especially in this area, that are in the high 20s, low 30s for average nitrate levels in the groundwater. Those are extremely intensively farmed townships right there. Of the possible 144 pivots in those townships, there's some where there's in the neighborhood of 120. So you got a ton of groundwater being pumped, a lot of nitrogen fertilizer going on, and again, in these really, really sandy soils. In the Upper Elkhorn, you've kind of got the same situation. In the intensively farmed areas, here we got some that are in the 9s, but you have some high teens, low 20s as you move down Highway 20 to the east. Over here, these 8 townships would be part of the Brazil Groundwater Management area. Both the Lower Niobrara and the Upper Elkhorn NRDs are 2 of the NRDs that participate in that program. Normally, from an NRD perspective, a lot of these groundwater management areas are managed on a progressive phase type of program. For the most part, in these programs, the triggers are roughly the same. The meat of the programs and the guts tend to be different between districts. You can see required BMPs move over as you progress in the program. The recommended practices and the encouraged practices usually become required, and so on. When you get out here to the phase 3 areas, they tend to become a little more restrictive and regulatory, and some NRDs have even went out to a phase 4 situation, but I'm not sure what triggers those would create. In the Lower Niobrara, you can see the white areas are phase 1 areas. The yellow areas are part of our phase 2 program. That constitutes 90% of our irrigated acres. So almost all of our irrigated acres that are certified are in a phase 2 designation. In the Upper Elkhorn, you can see you got a lot more phase 1 area designated by the green, a few phase 2 areas, and then they just back in February incorporated all this red area into a phase 3 management level. Their phase 3 management level is going to look a lot at residual soil nitrates and do some testing and work with some BMPs with producers in those areas. One of the main things that we get from this, from our phase management program, is we get phase reports back from the producers on a yearly basis. They can file these online, and what we have found is over the years we've accumulated all this information that the producers have given us, but we haven't done anything with it. So a couple years ago, I took Lower Niobrara's information, and Mr. Wayne Fredericks back there, he took the Upper Elkhorn's information, and we filtered the data. We dismissed some of the extremes at the top and the bottom, and then we threw out anything that we would regard as unrealistic in a growing situation. We analyze the information to kind of produce some comparisons and some scenarios, and we take this information out and show the producers what they have told us. Because when you sit down with a group of them or run into one of them on the side of a road, you know, in their mind, they are doing everything they can to help with the nitrate problem. They are doing everything in their power. They're doing everything right. And I think at some point in time, all of us think that we are doing that. But when you put this information together, it tells an entirely different story. What it's telling us, at least in the Lower Niobrara, is that 73% of our cornfields are having nitrogen applied over the recommended rate, which is the UNL algorithm rate. That's down from 91% in 2013, and you can see here the distribution of those overages. About half of those are in the 0.1 to 50 pound range. Yet still have a significant number, about 20% in the 50 to 100 pounds over the recommendation. It was nice to see that in the Upper Elkhorn's analysis, they found the same thing. They were able to go back to 2003 and show that 77% of their fields were receiving nitrogen over the UNL algorithm. The distribution is not exactly, but it is pretty close to the same, maybe a little bit more here on this higher end of 100 to 150 pounds over. Mr. Fredericks was also able to show that as you were applying nitrogen over the UNL recommended rate, you were also increasing your average soil nitrates and your average irrigation water nitrates as you were doing that. What was surprising to a lot of producers, a lot of crop consultants that we've shown this to, is as they've been increasing these nitrogen rates over the UNL recommended rate, they are not increasing their yield. We've got a trend line that shows about less than a 2 bushel increase from here at the recommended rate to as much as over 200 pounds over the recommended rate. At the lower Niobrara, I ran it out more of like a 50 under, 50 over type analysis that UNL used to do these studies all the time. And it's showing, again, no increase in yield from 50 under out to the maximum of 192 over. Another thing Mr. Fredericks did when he analyzed this is he created an adjusted yield, so you can kind of compare apples to apples. And all that really basically does is takes bushels off of the yield to pay for the extra nitrates that they put on the field. So as these guys are sitting in the coffee shop, this producer's saying, well, you know, I yielded 210. Well, his neighbor across the road might have done 216, but in essence, when he took bushels to pay for the extra fertilizer he put on, he was only able to yield 199. In all of these, the greatest economic return was always realized by applying the recommended rate. At the lower Niobrara, we broke it down into different types of corn acres. We had corn on corn acres, which are about 65% of our acres. Corn on specialty acres are 5%. That's corn after alfalfa, potatoes, or something like dry edible beans. And then the remaining 30% of the corn acres were after soybeans. So that's a weighted average, and you can see the first bar is the recommended rate, second bar is the actual applied rate, the third bar is going to be your expected yield, and the last bar is the actual yield. So you can tell there, again, as we're putting on more nitrogen, we're not realizing the expected yields that we're counting on. Break it down into dollars and cents. I'm just going to go over here to the average. The extra nitrogen that we're putting on, about 23 pounds. We're missing our expected yield by 2.3 bushels per acre. On a per acre basis, that's an opportunity loss of $19.62. In our little district with 240,000 irrigated acres, that's $4.6 million of opportunity loss in over application and not realizing the subsequent yield. I like to look at this groundwater management issue as a three-headed monster. And I think every good groundwater management plan needs to be comprehensive and cover all three of these heads per se of this monster, because the nitrogen always is the direct one that gets all the blame, but you have water application that's quietly pushing those nutrients down through the vadose zone and into the water table, and then you have the soil health part that everybody thinks is a little goofy, nobody really respects it, although we are gaining ground there, but nobody maybe realizes the importance of this goofy soil health guy on the end. So when you look at the nitrogen head, generally the basic relationship between corn and yield, corn yield and nitrogen is curvilinear. If you've taken any econ, you know there's a law of diminishing returns in there, and of course that changes as the economic values change from season to season. I had all this tons of corn yield data, nitrogen data. I was going to put it on a scatter plot, and this was the graph I thought I was going to get. This was the graph I got, which is basically a flat trend line showing that we're getting, again, no increase in yield as we are increasing the amount of nitrogen we are applying. One thing that we are seeing in this graph is here about 150 pounds of nitrogen, 200 and 240. You see the stacking right here. I can go to the CSV and look at that, and that is one producer, one large producer, putting 240 pounds of nitrogen on every field that he is farming. He is not going through and figuring the need on an individual basis. When Upper Elkhorn did their analysis, they have indications that 28% of their producers are not treating their fields individually. They're just mass fertilizing the fields. So that's kind of one point of emphasis we kind of pulled out of this also. When you look at the water application head of the monster, generally, the basic relationship between corn yield and water is linear. Water is considered the #1 limiting factor. We all know about the leaching and the runoff, and in a perfect world, you would like your precipitation and your irrigation to equal your evapotranspiration number with a little bit of a efficiency factor in there. So again, I thought I could make a graph like this, and I cannot in our district. Over these 3 years, as you can see, we basically are not increasing our yield as we're increasing the amount of water applied, and we have an extremely large range from 5.4 inches to 31.2 inches. And these are kind of the costs associated with that on a per acre basis or a per 130 acre pivot type scenario. Show this at nitrogen certification to a bunch of producers and the ag lender walks in, it turns some heads because the ag lender does not want his producers down over here in this area with high inputs, low yield. He wants all his up here. He wants to be this guy, not this guy out here, because there's about $80 an acre difference in his inputs just in water. I thought I'd look at soybeans just to see what it's doing there, and as we're increasing the amount of water we're putting on these soybeans, that trend line actually decreases a little bit. We actually had a huge range in that graph too, and the cost per acre difference in that range. One thing that this slide kind of tells me is we have producers that are essentially flood irrigating with center pivot systems. When you get out here, you know, past whatever your ET would be for those particular years. And it's also probably why in our district we figure we're pumping about 90 billion gallons of groundwater every season. In a wet year, you would think like 2018 when you have a little bit more precipitation. You got 19.12 was the ET north of O'Neill. 19.84 was the growing season precipitation. Theoretically, you shouldn't have had the water or water at all, but yet our reports show that we put on 18.4 inches per acre with our metered reports. The other guys that were just reporting offhand were reported at 10.5 inches per acre. You do the math, we're still getting an over irrigation of over 7 inches in that season. And we had all the rain in the world that year. Granted, you can give the producer some credit because timing and amount of precipitation affects it, soil type affects it, best management practices affect it, but that's, you know, that's how the numbers come out when you do the math. When you think of the goofy little soil health head that was on that monster, the thing with the soil health movement, and it can start as simple as crop residue and turn into organic matter, but it helps you battle the other two heads. It helps you with the nitrogen cycle. It also helps you in your water use by lowering your ET. And when I graphed the information on corn yield and organic matter that was in the reports, that was the one graph that looked good. As we're increasing our organic matter in these sandy soils, we are increasing our yield. This would indicate about 10 bushels a percentage point when you go from 1 to 3. So that's the information that I have from the lower Niobrara and the upper Elkhorn on our phase report information that we collect and put together.